In this lesson video for Unit 6, Day 6, this is our final lesson video for Unit 6, we're going to be talking about the applications of our circle equations and their graphs. Most of what we do today will actually be done working just with the equations. We won't be doing a whole lot of, or really any graphing, but we are dealing with the concept of the graph. And so we're using our equation to help do that. And so I want to remind you from lesson 6.5 that our circle equation was anything in this form: x minus h squared plus y minus k squared equals r squared, where h and k are the coordinates of the center of the circle and r is the radius. So we're going to be using that model with these application problems. So we're just going to roll right into our examples. This is really the only content we're going to use, and we're just going to apply that in a lot of different situations. Now, we might also get to where we talk about area and circumference formulas, but right now we're using this. So this first problem talks about a local radio station that's located at these coordinates. We do not have to graph this, but if this is the location of our radio station, then it has a broadcasting radius of 140 miles. Well, radius is 140 miles. That makes this the center, HK. Well, I could write an equation that represents the outer limit circle of the radio station's broadcast. So kind of what that means is, if I have the center at 5,2, then there is a radius of 140 miles around that center that the radio station will be able to broadcast clearly to. Okay, so anything more than 140 miles away from that center in any direction would not be in the broadcast area. So these spots outside the circle would not receive that radio signal. And so we have a situation where there's a house located at negative 9581. And the question is, will we pick up that station? What that means is this house located inside this circle, or at least on the circle? Any point exactly on the circle or inside would be in that broadcast radius. So what we're going to do is we're going to use our equation for this circle to answer the question. So first we need to write the equation of that circle. Okay, step one, our equation would be x minus 5 squared plus y minus 2 squared equals 140 squared. And I'll leave it as 140 squared right now. We would normally write that in. And so what I want to do with this is I want to test this ordered pair, x, y, and see if it actually is equal to that or less than. So I'm actually going to change my equation to be less than or equal to. I want the distance between this point and this point to be either on the circle or inside. Okay, so not just equal to, we're going to make it less than or equal to. And if this is true, if these fit this inequality, then my answer is yes, that it'll pick up the station. So we're going to plug in negative 95 for x. We're going to plug in 81 for y. And we're going to see, I'm going to leave this empty. I'm not going to write the equals or less than or equal to symbol yet. We're going to see how that relates to our 140 squared, which is 19,600. Okay? So we're going to test this out. Negative 95 minus 5 is negative 100. And 81 minus 2 is 79. So we're going to square each of those. Negative 100 squared is 10,000. And 79 squared is 6,241. We're going to add those together, okay? Giving us 241, which is less than 19,600. So what that means is this point is less than 140 miles away from the radio station, so it is in the broadcast radius. So my answer is yes, because 16,241 is less than 19,600. If we had gotten a value bigger than 19,600, it would not have reached, the signal would not have reached the house. So we're going to do kind of some more problems like that, and this next problem is a lot like that, but we're talking about a local restaurant with a delivery radius, okay, again, that gives us a circle, and we're just going to start by kind of going through the same problem, but just piece by piece. So first we're going to write an equation for the situation. Local restaurant is now delivering to a 15-mile radius, that means R equals 15, and the restaurant is located at 1, 2, that's HK. So we plug into our formula, x minus 1 squared plus y minus 2 squared equals 15 squared, which is 225. So that's the first part. We're just writing an equation. Okay, so the second part, you live at the point 10, 11. Will they deliver to you? It's the same kind of problem. I'm going to use this as my x and this is my y and see what the relationship is to this 225. Is it less than 225, equal to 225, or greater than 225? So I'm going to use 10 and 11 as x and y, making this 10 minus 1 squared plus 11 minus 2 squared. And we're going to see how that relates. 10 minus 1 is 9. 11 minus 2 is also 9. 9 squared plus 9 squared is 81 plus 81, which is 162, which is less than 225. So you live within the delivery radius, so your answer is yes. They will deliver to your house. Now they ask what the area is of that delivery region. Remember, this is the equation of a circle. So they're just asking what is the area of this circle, which means I need my area formula, pi r squared. I know my radius is 15, so all I'm doing is taking that 15 and plugging it in for r. So it's pi times 15 squared, which is pi times 225, which rounded the nearest tenth is 706.9, and that would be in square miles. All right? And so this is how we are applying this formula to some real-life situations. All right, as we move on down the page to our third example, we are given that a circle has a starting or original radius of 8 centimeters, but then it is stretched. So this is a transformation of some sort. Okay, meaning we have what's called our pre-image. We are transforming that into an image in some way. So this is our pre-image, our original figure, a radius of 8 centimeter circle. And the new area is 4 times that of the original circle. They want us to find the radius of the new circle. Okay, so I'm going from an original r to what we would call an r prime. Okay, that prime notation for our transformations. Well, that means since I'm using area, all I really have to do is look at my area formula. So I'm going to start with area equals pi r squared. I don't need to calculate the original area. Okay, we're just working with the formula. Okay? The new area, this is our original, so our area prime, our new area, would be 4 times the original area, which means that it is 4 times pi r squared. And so they want to know what the new radius is. So what we're going to do is work with the numbers that we were originally given. The original radius is 8. So the original area is pi times 8 squared, or 64 pi, which I'm going to leave written as a number in terms of pi. I'm not actually going to multiply that out. But then whenever I multiply that like this, I get a new value in terms of pi, which 64 times 4 then is 256, because I'm just going to multiply these two together and leave it in terms of pi. Okay, so it's 256 pi. That means my area formula for my new circle which is still pi r squared, but this is our new radius. This equals pi r squared. So 256 pi equals pi times the new radius squared. Well, all I have to do is solve this for r, which means I can just cancel my pi from both sides. Remember, we divide both sides by pi to do that. So r squared for the new circle is 256, and we just take our square root of both sides. Okay, so the square root of 256 is 16. So our original radius of 8 gives us a new radius of 16 centimeters. In class, we're going to look at why this transformation takes place this way and what is maybe a shorter way of doing this problem, but we have to start with kind of the longer way. Okay, example 4 is a lot like number 3. We're still starting with a given circumference though, but then they want the radius when we're applying a change to an area. We're going to cover this one in class, all right? So as long as you have 3 done, we will use that as a starting point to be able to do 4 in class together. So I want to move down to number 5. Number 5, we have a circle that's created by this equation. And then we're saying that we're going to stretch this circle so that its area is doubled. And they want the area and radius of the new circle. Okay, so we're going to take a look at this first, and we're going to look at the important information. Remember that area is pi r squared. Well, in our circle equation, this number at the end is r squared. So I know that the original area of this circle is pi times 81, because 81 is r squared. But then it says that the circle is stretched, so the area is doubled. So I'm going to double this. So my new area is twice as much as 81 pi. Okay, so I'm going to take 81 and double it. And I get 162 pi. But your formula is still pi r squared. So this r is my new radius. So to figure out what the area and radius of the new circle are, I've already done the area, I just have to simplify that. My a prime, or my new area, is 162 times pi, which is about 508.9. Okay, and we aren't told a unit of measure, so that's all I have to put. But the new radius, you can call it r prime if you want, means that I have to solve this for r. So I'm going to cancel out pi on both sides and take the square root of that 162. And we get that the new radius is about 12.7. Okay, so a lot of work with formulas. Okay, part B we're also going to take a look at in class together, so we're going to skip over that. So in our final example here, again, we're just going to do part A. It's a lot like what we just did. We've got an original equation for our circle, and it says that the circle is moved 2 units down and 5 units to the left, and they want us to write a new equation. Okay, so we're going to do this, but I want you to realize what happens when I take my circle. All I'm doing is moving it 2 units down and 5 units left. So there's my new center. Whatever the radius was, it looks like that. Now, my drawing isn't really good here. The circle doesn't really change size with this transformation. All we're doing is translating it. So we're taking our center and we're going down 2 and to the left 5. This to the left 5 units to the left, changes your h value. So we take our original h and move it to the left 5 by subtracting 5. And we take our original k value here, this 2 units down subtracts from the k. So we take our k value and subtract 4. I'm sorry, not 4, 2. Okay? So all we're really doing is getting a new center by applying these changes. Okay, so our original original h value was 7, so I'm going to subtract 5 from that. 7 minus 5 is our new x-coordinate of the center. And then the y value of the center, I'm going to subtract 2 from, which was 4 originally. So our new center is at 2, 2. So that just changes this part of my equation. So my new equation is x minus 2 squared plus y minus 2 squared, and it still has the same radius. So it's still radius squared 49. Okay, like I said, part B we will take a look at in class as well, but this gives you a starting point for how we can apply equations of circles.